and then we can see what everybody's saying. So today we've got Digby Sowerby this morning, and he's already had an introduction to the festival today because he was Matt and Aidan's guest on the morning show at 8 o'clock, where he gave a very, very brief overview of what he's going to be talking about today. And he mentioned those robots. How are robots going to be growing wheat in our fields in Dorset, and why, and what's his connection, and who does he work for, and all that stuff. So Digby, over to you. Tell us the answers. If you want to ask questions, pop them in the chat, and there'll be a question and answer session at the end. But until then, stay on mute, and we'll let Digby do his stuff. Over to you, Digby.
Great, thank you very much, Penny. Thank you very much, and thank you very much for having me at Festival of the Future. It was very good to speak to Matt and Aidan this morning. It's good to see such positive people around. And like you say, Penny, I'm going to be talking about agritech in Dorset and the 5G Rural Dorset trials, which are being run by a consortium of partners in Dorset. I'm going to start firstly with a little bit about, if I can move this slide on. There we go. So I'm going to talk a little bit about the background to everything, really. So who I am, who I work for, and what 5G Rural Dorset is. So I'm Digby, and I joined Wessex Internet in April this year. Wessex Internet is a family business and was set up out of a family farm. Essentially, they were fed up of not being able to get good enough connectivity. And so the family decided to set up their own internet company. And they specialise in providing internet to rural areas across Dorset and also into some neighbouring counties. And they started off as a wireless company, so providing wireless broadband to people, but now have started doing fibre to the property. So that's planting fibre into the ground. And the unique thing about Wessex Internet is that it has always worked very, very closely with farmers and landowners to be able to spread the network. And we work very much on a consensus basis by building relationships with farmers and communities, and then providing services to the people who enable us to reach other people across the county. So it's a real sort of community-led effort in providing internet to people. And so this made us perfect partners for the 5G Rural Dorset trials. And the 5G Rural Dorset trials are DCMS funded trials looking into how we can best provide 5G to rural areas in the UK, and Dorset is a test bed for that. So some of the other partners we're working with include Dorset Council, who are the lead partner, and are very proactive in the digital side of things, as we can see over these three festival days. We also have the Satellite Applications Catapult, which is a big UK tech and innovation institute, as well as a load of other organisations with specialisms in 5G and other technologies around. And like I say, so Wessex Internet's perfectly placed for the 5G Rural Dorset project because we have this close connection with farmers, and also because we're an infrastructure provider. And really, to be clear, it's the fibre infrastructure which is able to enable 5G in rural areas. And so the 5G Rural Dorset project, like I say, is a project looking at how we best deliver 5G in rural areas. And it's split into 4 main activity areas, looking at coastal safety, looking at commercial connectivity in rural areas, looking at an innovation makerspace, and then also looking at agriculture and aquaculture. And that's the work package I'm going to talk about today, and that's the one Wessex Internet is leading on. So firstly, I thought I'd give a bit of information about the scene of agriculture at the moment. So I've spent a lot of the last few months with our partners, talking to farmers and talking to lots of industry players to understand the environment and see what the future holds. And currently the situation is not all horrendous. 4G is providing a lot of benefit to farmers. So we see in this top left picture, we've got a 4G modem on top of a tractor, which essentially connects the tractor to a 4G network. And this means that the data collected on the tractor is being able to send via a 4G network to the internet and back to the farmer. And this has been led by some of the big manufacturers, and is becoming quite commonplace in farming. The two issues are the limitations with 4G, so not being able to send enough data, and then also the connectivity, so not having the 4G there in all the areas. LoRa, which is this sort of signal you see at the bottom, this is a private organisation which provides private networks to whoever, essentially, and it can connect lots of different devices using a 4G or a fibre connection itself to each other. So these are mainly sensors in the field. So if you've got a temperature sensor, for example, or a soil sensor, it's able to collect that data and send it back. But again, these systems are quite expensive and take a lot of fiddling around to install the system. And 5G, we're really trying to explore how we can make that better and also combat the difficulties there are in 4G. Two of the main pain points in farming at the moment, which we've heard a lot of during the trials. One is incompatible devices. So farmers spend a lot of time very frustrated, not being able to transfer information between devices, and spending a lot of time processing information to be able to make them compatible between devices. So when I say devices, I mean that is a field map being able to talk to a tractor, a field map taken from a satellite being able to talk to a tractor about where to plant a seed or where to drive, for example. And then another issue is at the moment that a lot of the agritech solutions which have been provided, so your drones, your robots, they're starting to go into farming, but it's been very, very slow. And the big issue is that a lot of these devices aren't built with connectivity in mind, because they go based on the assumption that there is not connectivity. And so, for example, at the moment, drones, a farm will go and fly a drone, and then take the information off the drone and plug it into the computer. And really with 5G, we're trying to automate this process so the farmer doesn't have to spend his time doing that. So I'll next go on to 5G. If I hit slide, hopefully it will go. There we go. Okay, so a bit of background about 5G and what 5G is. So I'm not sure exactly who I'm talking to, so some of you might have much better knowledge than I do, as I'm not a technical person. However, 5G is a form of wireless technology, and it's sort of a range of new technologies that have come together to provide wireless connectivity, to be able to connect devices essentially to the internet. So to connect the mast to the internet, there's usually the fibre optic cable, and that's provided, for example, by Wessex Internet. And then we're looking to explore how 5G equipment can be added to the mast and also in the background to be able to connect devices more effectively and more efficiently. Now, data is transferred wirelessly using radio waves. Radio waves can vary in length, and generally when we say low frequency radio waves, these are waves which can not transport as much data, but can transport the data a lot further. And when we talk about higher frequency, we talk about lots of data being able to be transferred, but not being able to transfer as far. And the biggest misconception about 5G is that it's just the higher frequency stuff, so that it's just high amounts of data being able to be transported very quickly. That's not really true, because 5G is possible in all the different radio wavelengths. It is in fact a release of a range of radio wavelengths. So you can have low frequency 5G, high frequency 5G, and millimeter wave. as you can see in the diagram at the bottom right. Now, the low frequency stuff is useful generally for connecting sensors. So whether, like I mentioned before, soil sensors or temperature sensors, and bringing all that information in just continuously throughout the day for a long period of time. And the great thing about 5G is that it's all about having this process more efficient and more effective. And so the devices on the 5G side of things can last up to 8 to 10 years because of how effectively the network is built. The high frequency 5G is looking at transporting large amounts of information. So that's large images or telematics data from tractors and transporting that directly onto a farm management platform, for example. And then we have the millimeter wave, which we're not looking at particularly in the trials and is much higher because it only travels maybe a couple of 100 meters. But it's looking at collecting large amounts of data all at once. And so that's a bit on 5G. And really in the 5G trials we're running in Dorset, we're looking at two main frequency areas. So the low frequency areas you see on this chart, around 700 megahertz, and also the higher frequency between 3.4 and 3.8 gigahertz for these use cases. And so if I move on, looking at 5G for farmers. So as I mentioned, we've spoken to a lot of farmers and tried to understand the main needs when building 5G into the system. And so the two main aims we have in the agriculture and aquaculture workpiece of 5G Rural Dorset is to design a 5G network that works for farmers and to build a 5G ecosystem within farming UK. And to do that, we need to address these main issues. Affordability of the system, so a farmer's not going to pay a large amount of money to be able to connect devices. Reliability of the technology. Technology needs to last a long time. It needs to not get in the way of normal activities. And it needs to be easy to use. And interoperable. So all these different agri-technologies which are coming along need to be able to work together. And that's a big issue in the industry at the moment, is that technologies just don't work together. And so, as I mentioned briefly before, there are two main areas we're looking at in terms of the 5G, the lower frequency and the higher frequency. Now, the benefit of the lower frequency is that you're able to transport data much further. So we might be able to have a Wessex Internet mast here, and that can collect data from maybe 10 kilometers radius and just continuously collect this data over time. And these devices can last a long time and they can be low cost. And it can be a cheap way to be able to collect lots of environmental data for farmers. And then looking at the higher frequency stuff, this would be an install Wessex Internet or anyone would do on a farm. So putting 5G on the farm itself. And this would be for the more higher tech solutions. So we're looking at the cameras on the drones or the robots or the field cameras. And it's all about transferring information directly onto a system and also automating processes. So stuff is being able to transport much quicker using 5G, and a lot more data has been able to be transported as well. And so the trials in Dorset, so we have 4 main trial sites. One is in the west, is a big dairy farm in the west, and so we'll be looking into some use cases there, which I mentioned in a second. The second are charitable farms in the north. And we'll be looking at some of the more advanced use cases up there. We also have Kingston Moorwood College just outside Dorchester, which is aiming to be the centre of agritech in the southwest, essentially, and that's what they're really pushing for, and are keen to see what 5G can do for them to be able to attract both young people into the area, but also private investment into the area to be able to test their technologies too. And then we also have an aquaculture operation in Portland Port, which is a super fascinating part of farming that I've never been involved with before, but it is growing really quickly, and there's a fantastic strong aquaculture organisation within the southwest of England and especially Dorset. And so the trials themselves, so We're still in the planning phases of the trials, so we're still trying to bring together the partners and work out exactly how the trials will run. These are the main ideas that we've come up with so far and the main things that we're wanting to do. And I'll just go through each of them briefly, one by one, just to give a little bit more detail on those. So firstly, we have a farm digital twin. Now, this is the concept of having a virtualized farm so that you're able to collect lots of information from across the farm and always have it live on your device. So if you have your computer in front of you, you're able to see the soil temperature, the carbon sequestration rate, the biodiversity levels across the farm all the time in one place. And this can be really useful for farmers to be able to both capture the data to see what's going on in the farm at the moment, but also to be able to build a database of historic information to start measuring stuff against each other, and also using it potentially as evidence to present to government if they're looking at their CO2 emissions or how beneficial environmental measures are. And so really you can see this as just a program on the computer which is able to tell you lots about the environment around the farm all the time. And it's all about giving farmers more information to make decisions. Also on this, the ability to build in algorithms which can suggest to the farmer the best time to spray their crop, or be able to predict when there's going to be a disease or a pest onset, just based on historic data, and building that into the system and understanding both the local environment and also wider data sets. So it's a fascinating concept, and you'll hear this digital twin concept across many different industries. Live operations info, terribly named, apologies for that, but the live operations info is all looking about taking information from the tractor and getting it live to your mobile phone, so a farmer can see exactly what's going on the farm all the time. So you can see the yield coming in from the combine, you can see how much fuel was used in this field, and so on. Then we have instant drone images. So we're working with one of the leading drone companies in the UK in agriculture. And at the moment, how they get their data back to the farmer is by flying the drone, taking the drone down, going home, taking the information out of the drone, put it into the computer, waiting a few hours because it's such a large amount of data to upload that to the computer, and then process it and send it back to the farmer. And really what we want to do in those trials is for that drone to be able to send the information as it's flying directly back to the farmer to make a decision to send directly to the combine or to the drill or to the sprayer for precision farming purposes. So they're able to make farming more effective, use less chemicals, and be more efficient in terms of seeding. Excuse me. So automated robotics. So this is the interesting trial, and we've applied for a trial extension for this, and so we're hoping that we're able to run this trial. But this is working with the leading UK agricultural robotics company, looking to see whether we can grow a whole field of wheat using robotics. So that would be a world first to do that. And we're looking to see whether the robot can both map the whole field, weed the field, and drill the seed to produce a wheat crop. And robotics, it's still early stages, and like I say, they've been built often without connectivity in mind. And so it's really interesting to see how 5G might be able to make robotics a commercial reality into the future. And then looking at the dairy side, we're working with a couple of camera and cow tag companies to see how 5G can enhance their products at the farm to be able to improve animal welfare and understanding of animal behavior. So, for example, if a cow is lame, you can try and look amongst your cows and you've got to try and identify it, and it's very tricky to do. And there is technology out there which can predict or can identify when a cow is lame, but we're looking to see how we can make that more effective using cameras, and also how it can be more commercially viable by reducing the cost of everything. And again, understanding usage is similar to operations info on the other one, all about being able to understand your water usage, what the milk temperature is in the tank at the moment, and that side of things. And then finally, we have the aquaculture side of things. And there are two main use cases here. One is looking at the water data. So currently, the aquaculture operation we're working with, they would deploy a boat every few weeks to go out and understand information about the water. That's looking at salinity, oxygen levels, turbidity of the water. But we're trying to see, and there is technology out there which can sensor water at the moment, but there's nothing that is commercially viable for a farmer to be able to do this. And really, we're looking to see how 5G can make this process efficient. So a farmer can build up a whole historic database of water information and then compare this against the impact it has on the stocks. And so in our case, it's a shellfish and seaweed farmer. And we're looking to see what effect, for example, turbidity would have on the growth rate of shellfish. And indeed, the farm remote monitoring, this is about using underwater cameras and being able to transfer the information, those images, using 5G out in the water, and to be able to understand seaweed growth rates or shellfish growth rates, and also biofouling, which is buildup of algae on the stock, to be able to not have to deploy the boat, which of course is inefficient and time-consuming and costly. And so that is a run-through, and I'm sorry that it's not quite so interactive as I'd like it to be. That's a rough run-through of the things we're planning on doing, and we're in the process of doing at the moment. And so thank you very much, and I'd encourage you to reach out to me and get in touch if you have any questions, or if there's anything that you might be interesting for us. Or for yourselves, and then also do reach out to 5G Rural Dorset project as a whole, which is running things, like I say, not only in agriculture, but in commercial rural connectivity, in coastal safety, and in a maker space, innovation space. So thank you very much. And I will also plug Gary Littledyke, who is from the 5G Rural Dorset project, and one of my colleagues who will be speaking at 3 p.m. today. Thank you.
Digby, thank you so much. As somebody who doesn't come from a farming background or from a 5G background, there were quite a lot of new words there that I had to get to grips with.
Okay, I'm sorry.
No, it's all good. Fascinating. Having heard about the project in the early days, it's come so far already. So thank you so much for that. Now, this is the opportunity where people can, having digested all that information, can come forward with any questions. Does anybody have any questions? Would you like to post your questions in the chat bar? I see Pete's made some comments there while you're having a think about what you might like to ask. Pete says, love the idea of IoT and farming, so many potential benefits, not just economic growth of the businesses, but the protection of the natural environment too, win-win. And certainly I was thinking that if you can make your productive land more productive and more efficient, it then leaves more land free for rewilding or other projects that protect biodiversity as well as improving the biodiversity on the land that you're managing intensively.
Yeah, absolutely. I mean, it's sorry, Penny.
No, have I got that right?
Yeah, absolutely. I think you're spot on, and indeed, Pete's absolutely true. IoT offers a massive ability to have an incredible insight into the environment reacts to different practices, so different farming practices, but also different changes in the environment. And at the moment, we have measures in labs to try and guess what's going on, but we don't really understand. And so to have a local, live, reliable piece of information that's feeding in, it's quite incredible what that can do, both in terms, like you say, of being able to farm more productively, but also farm in a much more environmentally friendly way in terms of reducing CO2 emissions and increasing biodiversity.
Thank you. I see Joe's got her hand up. Joe, would you like to unmute yourself and ask a question?
Yeah, Yes, I would. I've got several questions actually. Really good, Digby. It's so great to see agritech coming to the fore as part of this, and the aquaculture as well. So really pleased. I just wondered if you had any correspondence with the Handsfree hectare at Harper Adams University, whether you were using their expertise in some of their tests that they are running. I just wondered if you had.
Yeah, absolutely, fantastic question. And of course, Handsfree hectare, it is the sort of the symbol of modern farming in the UK. It's sort of the go-to place for automated farming. And the agronomist working on 2 of the farms was one of the partners in that project. So we have close contact with the people from that project. But yes, I do need to reach out and speak more to them about what they're doing, because at the moment they're looking to create the Handsfree farm. So they've done the Handsfree hectare and now they're looking at the Handsfree farm. So I think it's fantastic what they're doing there, and definitely relatable to what we're doing here.
Yeah, I'll take that subject a bit further with you after this then. So also, yes, from what we discussed yesterday as well, from the high potential opportunity for agriculture, we definitely need to incorporate a little bit more on this, because I think that changes everything. It's just changes the scope of it completely, and I would ask you if you could save this presentation, because I think that it would be ideal to give to Southwest Agritech, which is all the 6 LEP area in the Southwest, which I chair, our next meeting. So I'll email you to try and book you for that if you'd be willing. So say exactly this presentation would be absolutely fine. And I also have a bit of drone footage as well from Hummingbird, which I'm going to share with you afterwards as well, which I used at Farnborough a couple of years to show the cross-tech activity between aerospace, agri-tech. It was a really good demonstration. So I'll share that with you. Anyway, I think that's me finished then, Digby. Thank you so much. Thank you.
Fantastic. Thank you, Joanna. And yeah, I'll send those through. And indeed, Hummingbird are the company that we're working with in the trials. So really exciting company to be working with.
Thank you, Joe. Thank you for that. You've got yourself another booking there. And just for everybody's information, we are recording this session, so it will be available on YouTube for anybody who does miss it. So that's another way of catching up. Julie's got a question. Julie, would you like to unmute yourself and ask your question? Julie, can you hear us? Multitasking. Okay, she's coming back to us. I think she's on her way.
Sorry. Can you hear me?
Yes, we can hear you.
Okay, I was just wondering, regarding the weeding, can you set it up to preferentially take out things that are pernicious weeds and leave things that are more of ecological value? Do you know yet about the weeding to do with the robots?
So I think that's a super interesting question, because weeds can have benefits as well. And especially weeds can interact with crops in a way that's beneficial. And as I'm sure you're aware, it's all about soil health and capturing carbon into the soil. So in terms of the agritech involved, I'd have to defer to our agritech partners on that. So it would be the robotics company that we're working with in terms of what they're doing now. I'm sorry, that's not more helpful.
No, that's okay. I understand. Thank you very much. I'll look them up. Thanks.
Okay, thank you.
Would it help, Julie, to leave your email address in the chat bar, and then maybe Digby can come back to you? Would that be all right, Digby?
Yeah, that's fine. I work at the Game and Wildlife Conservation Trust over in Fordingbridge.
Okay, fantastic. Yeah, I'll definitely get in touch with you, Julie. It'd be good to involve you in the trials.
Yeah, we would. I think we'd be interested because we're local. That would be quite useful.
Yeah, fantastic. Thank you, Julie.
Lovely you've joined us today, Julie. Thank you very much for your question. Any further questions for Digby? Or has he given us so much to think about? We haven't quite been able to process it yet and come back with any questions. No, looks like we're done then. There are some people I can see on this call who do have more knowledge about this project. Is there anything that you would like to add people from my team, for example, that you'd like to add or draw out from Digby's presentation? This is your moment. No, looks like everybody's very happy with what you've told them.
Okay, brilliant.
Very happy indeed. Well, that's absolutely great. Yeah, Joe's another comment from Joe. GCWT. Do we know what that is?
Game Wildlife Trust.
Yeah. Yes. Sorry, just coming in again. I always included the wild fish in the HPO and the work that the Game Conservancy did at East Stoke, because I thought it was important that we demonstrated wild fish research as well. So I've got some links there, Digby, if you want, but also sounds as though head office at Fordingbridge have been in touch in any case. Looks like
Julie's in touch with them, so that's really good. People saying a great talk, thank you. Yes, so any feedback, please do pop in the chat as well now, if you're finding this interesting. Do follow up on Garrett's still time to sign up for Gary's talk on the 5G programme more generally, more widely. So Digby was a sort of deep dive into this particular element, but